Semi-automatic kinematic viscosity tester. Remove the bubble wrap from the stirring head. Then take the stirring head off. Remove the foam board below. Take out the silicone pad. Place the silicone pad on the base of the bathtub. The bathtub is placed properly. Start adding the thermostatic solution to the water bath, temperature-controlled and constant temperature liquid ranging from 0 to 50 degrees. It should be added to about 1 centimeter away from the edge of the tank. When the high temperature reaches 100 degrees, the constant temperature liquid should be added to about 2 to 3 centimeters away from the edge of the cylinder, to prevent the high temperature constant temperature liquid from overflowing. After adding the constant temperature solution, place the protective rubber strip properly. The next step is to add the stirring head. The circuit of the stirring head should face the rear of the instrument. Place the 4 insulation covers on top of the stirring head. Then start connecting the circuits of the instrument. First, plug in this plug. The gap of this line must face upwards. Just plug it in directly. Don't exert force. This large plug is also notched upwards. Screw it in slowly. Power cable plugged in. After the lines are connected, power on and start the machine. Click on the Welcome interface to enter the main control interface. What is displayed on the interface is the current temperature of the constant temperature solution. That is, the temperature of room temperature. The channels A, B, C and D of the instrument are displayed here. Then return to the home page. System settings. Let's take transformer oil as an example. Set the temperature to 40 degrees for confirmation. Return to the main control interface on the home page. All 4 channels can be used. Take channel A as an example. Let's click on A to start. Then the status of the instrument is displayed as temperature control. The constant temperature liquid begins to heat up. This is the normal stirring state of the bathtub. When the instrument is controlling the temperature, let's make preparations for the experiment. Take out the viscosity coefficient tube. This experiment takes transformer oil as an example. A viscosity coefficient tube with a diameter of 1.5 was used. Depending on the different samples, the viscosity coefficient tubes used are also different. This is the verification certificate of the viscosity coefficient tube. This must be kept well, because there is a viscometer constant here. When conducting experiments, it needs to be input into the instrument. Next, let's prepare for sampling. Get the ear wash balls ready, flow guide pipe, and viscosity addition. This is a sample of transformer oil for the experiment. Sampling of transformer oil samples. Turn the viscosity coefficient tube upside down. Insert the ear washing bulb under the tube. Start sampling. Give a gentle pinch. Fill the 2 elliptical cavities. After filling it up, turn the viscosity coefficient tube over. Let the sample flow down slowly. Take out the viscosity clamp. The direction must be clear. There is a card pin on it. Press it, clip it onto this. Wait for the sample liquid to flow slowly to the bottom. Just go into this large cavity. The sampling has now been completed. We put it in the bathtub. Remove the insulation cover. Put it in slowly. The instrument has 4 channels. If experiments are conducted simultaneously on the 4 channels, they should be placed in order. If only one experiment is conducted, all 4 channels can be placed. There is no requirement for sequence. After the sample is put in, click to return to the homepage System Settings. There is no need to change the set temperature. The viscosity tube constant needs to be input. The viscometer constant on the certificate of the viscometer tube used. Input 0.4156 into it. The constant temperature time of the instrument is determined by the sample. If the viscosity is high, the setting time should be longer. Let's take transformer oil as an example. It's fine to set it for 60 seconds. Then return to the home page. Click on the main control interface. We take channel A as an example. Click the Start button of channel A. Wait for the sample's constant temperature time to end. The actual temperature here is within plus or minus 0.05 degrees. The instrument has just started the constant temperature timing. That is to say, the actual temperature was set at 40 degrees. The temperature range of the instrument is between 39.95 and 40.05. The timing has just begun. The current status of channel A of the instrument. It shows that the constant temperature has ended. A detection status will be displayed here. The next step is to start the experiment. After the constant temperature time is over, insert the deflector tube above the viscometer tube. Take the ear-washing bulb and slowly suck up the sample below. Suck up a little more than half above the second cavity. Now when the sample starts to pass down through the starting point of the flow, press the A timer immediately. Start timing. Now the liquid is flowing down slowly. When it flows to the final flow point below, press the timer A immediately to stop. The sample flows from the starting point to the ending point. The timing should exceed 200 seconds. If it's less than 200 seconds, it indicates that the selected viscometer tube is too thick. The sample flows slowly to the final flow point. Press A to stop the timing. Now the experimental results have come out. The instrument will start printing automatically. The viscosity of the sample is 10.036.